Hi folks, we're going to take a look at number 14 on page 439. So they're asking us to classify this quadrilateral DEFG with these coordinates. Now I've drawn here just a diagram of these four coordinates, and you'll notice I make no effort to be exact with where these things are because I'm just going to use this as a guide. Okay, so the two things that we use to classify quadrilaterals are how their opposite sides or sometimes adjacent sides are connected. So we're going to look at the slopes of all the sides of this quadrilateral to see if we have anything that's perpendicular, if opposite sides are parallel. Okay, and the other thing that we use is the lengths of the sides. So I'm going to use the distance formula to calculate the lengths of these four sides, and from there I should be able to make a determination as to what type of quadrilateral it is. Okay, so first thing I'll do is I'll find the slope, see if that gives me any information. Okay, so I'm going to go in order here. So I'll find the slope of DE. So this line here. So again, use subscripts as a way to identify what you're calculating exactly, or label this line and use, again, you can use a subscript to label your slopes. So here we're going to do 4 minus 0, so y2 minus y1 over 2 minus 10, x2 minus x1. Okay, and so here we have 4 over negative 8, so we have a slope of negative 1/2. All right, so let's keep going. Let's find the slope of EF. Okay, so here we have negative 6 minus 4. All right, and here we have negative 8 minus 2. So here we have negative 10 divided by negative 10. All right, so that's going to be equal to 1. All right, so now let's go to the slope of FG. Okay, so negative 8 minus negative 6. And then here we have 6 minus negative 8. All right, so what do we have here? We have negative 8 plus 6, so that's negative 2. And here we have 6 plus 8, which is 14, and that's negative 1 over 7. All right, so right away I can see that this is not going to be a parallelogram because I see that these opposite sides are not parallel. Okay, but again, that could still have a trapezoid if these two are parallel. So let's see what happens here. So the slope of GD is equal to, so 0 minus negative 8 over 10 minus 6. And so what do we have? We have 0 plus 8 over 10 minus 6 is 4. So that's equal to 2. So again, no opposite sides that are parallel. So this is not a parallelogram. It's obviously then not a rectangle. It's not a square. I do notice that these two adjacent sides, okay, DE and DG, are perpendicular to each other, but that in and of itself doesn't help us classify the quadrilateral. Okay, so if there's going to be anything special about this quadrilateral, it's going to have to come from the lengths of the sides. Okay, so let's start by finding the distance of DE. Okay, so remember the distance between 2 points comes from Pythagoras, so it's the square root of the difference of the x's squared plus the difference of the y's squared. Okay, so here I've got 2 minus 10 squared plus 4 minus 0 squared. Okay, so that gives me a 2. So negative 8 squared is 64. And here 4 squared is 16. So this is 64, 74, 80. So this is root 80. So let's keep going. And we'll start to see if there's anything special going on. Okay, so let's do EF. Okay, so same thing here. So we have negative 8 minus 2 squared plus, and then we have negative 6 minus 4 squared. So that gives us negative 8 minus 2, so that's 10, so that's going to be 100. Okay, and then negative 6 minus 4 is also 10 squared, or negative 10 squared, which is going to be, again, 100. So that's the square root of 200. Okay, so nothing special yet, so we're just going to keep plugging away. So let's do FG. All right, so what do we have? FG. So we have 6 minus negative 8 squared, and then plus, here we've got negative 8 plus negative 6 squared. So negative 8 plus, minus negative 6 squared. So let's see what that leaves us with. So this is 6 plus 8 is 14 squared, which is 196, I'm pretty sure. All right, and here negative 8, I just realized I think I made this here, we're doing FG. So here, negative 8 minus negative 6. Yeah, no, I did that right. So that's going to be negative 2 squared, which is 4. So plus 4. And so here we have, finally, we've got something interesting. So we see that these two adjacent sides are the same length. Okay, so still doesn't say anything official until we check that last one. So let's do GD. Okay, square root of. So GD, so 10 minus 6 squared, 10 minus 6 squared, plus here 0 minus negative 8 squared. So what does that give us here? So 10 minus 6, 4 squared is 16, and 0 plus 8, so 8 squared is 64. And so here, 64 plus 16, hey, that's what I had before, root 80. Okay, so something interesting is happening in that we see that adjacent sides, so not opposite sides, so it wouldn't be like a parallelogram or a rectangle, but adjacent sides are equal in length. Okay, and there's a couple of possible scenarios. Okay, one of them I suppose might be a rhombus, but it can't be a rhombus because they'd all have to be the same. So essentially what we have is we have two adjacent sides that are equal, okay, and then two other adjacent sides that are equal, but they're longer, okay. So what we have here is we have a kite. Okay, so again, I'm not making any effort here to be exact as to where these points are. It's just to demonstrate that when we have two adjacent sides that are equal and then another two adjacent sides that have equal lengths, what we have is a kite. Okay, so the fact that two of them happen to be perpendicular to each other, okay, say this here, doesn't really add anything to it. It doesn't make it a special type of kite. All right, so just to recap here, when you're asked to classify quadrilaterals, or it would be the same thing for triangles, the two things you want to look at are the slopes of the lines, so to see if you have anything that's parallel or anything that's perpendicular. All right, and the other thing you want to look at are the lengths of the sides to see if that's of any help. Okay, and in this case here, the only important relationship was that adjacent sides were equal, and because you didn't have opposite sides that were equal or parallel, we knew that it had to be a kite. Okay, that's it for this one.